Today's learning goal is to calculate velocity from the position time graph. Calculate velocity from the position time graph. Okay, so we're given some problems here in this worksheet. We're going to try to work through these. They're going to ask us some questions. We're going to have to interpret the graph, to read the graph, to come up with answers to these questions. So let's take a quick look here. We can see the vertical axis of our graph is plotting the position of an object, and this position is moving around. So at different times, it might be at different positions. In the horizontal axis, we have the time being plotted. So let's see, the first question says, what is the displacement during the first 8 seconds? So we're being asked to consider the time between 0 and 8 seconds, and we want to know what is the displacement during the first 8 seconds. Okay, so if you remember, displacement is written as delta x, or the change in the position, and this is the final position minus the initial position. So we need to figure out what is the final position, what is the initial position, and then we need to subtract these numbers. So the final position will be the position of the object at 8 seconds. So let's go and see if at 8 seconds the object is located at position x equals 10. Okay, so we're going to write 10 meters is the final position. And then the initial position, let's see, so the initial time will be at 0 seconds because it's during the first 8 seconds, so 0 seconds. The object is at the origin, so the x position at 0 seconds is 0. So minus 0, because 0 is the initial position of the object. And let's see, 10 minus 0 is 10. And we should write our units, right? So this is position in meters, so it's going to be 10 meters. And since we're being asked about displacement, and displacement is a vector, we should also specify the direction. And this is in the x direction, so we're going to write 10 meters in the x direction. X direction can be written like this, x with a little hat on top of it. So when you see that, that means it's 10 meters pointing in the x direction. This is a unit vector, but we don't have to get into that. You'll learn about that later on in some more advanced math classes. For our purposes, this just lets us know which direction the displacement vector is pointing. Okay, so 10 meters in the x direction. Also, if we want to get fancy about it, we can like put a little arrow on top of the x here to let us know, okay, this is a vector. This is the displacement vector. Okay, what is the velocity now between 8 seconds and 12 seconds? So now we want to find out, okay, what is the velocity between 8 seconds and 12 seconds? 8 seconds and 12 seconds. So we're going to be focusing on this part of the graph. And if you remember, velocity is the slope of the position graph, the position versus time graph, delta x over delta t. Right, this is how we write the equation for velocity. Well, if you remember from your math class, slope is rise over run, right? So here the slope, rise over run, the rise is x, and the run is t, time. So change in position over change in time, rise over run, is the slope of the position time graph, which is the velocity. It's the same thing as the velocity. Okay, so we basically, our goal here then is just to find out what is the slope of this segment here, this part of the graph between here and here. Okay, so we'll do rise over run. It looks like it's moving down 1, 2, 3, 4, right? So in the negative x direction, 4 units, 4 meters in the negative x. And then, okay, so let's write down negative 4 is the rise, and the run goes down 4, 1, 2, 3, 4, over 2. So 2 is our run. Okay, so for every 4 meters that it moves in the negative direction, 2 seconds pass. 4 meters, 2 seconds. Okay, so that's our rise over run. This is the slope of the position time graph, which is the same thing as saying the velocity. Okay, 4 divided by 2 is 2. And we have then that the velocity is negative 2 meters per second. And if you remember, velocity is a vector. So we should specify direction. It's going to be negative 2 meters per second. And this particle is, or this object or whatever, is moving in the x direction. So we're going to say in the x direction, we're going to write x hat. So that lets us know it's moving in the x direction. Okay, next they're asking, what is the total displacement? Okay, total displacement. So this is going to be over the entire time that we're seeing here in the graph. So between 0 and 13, 14 seconds, what is the displacement? Okay, so again, let's write down the displacement equation. Oh, and again, if you want to, let's like get fancy with it, right? You can put little arrows on top of your symbols to show that they're vectors. We can get in the habit of doing that. Okay, what is the total displacement? So displacement is the change in the position, x final minus x initial. And let's see, the final position of our object over here at 14 seconds, it is located at x equals 2 meters. The initial position is at 0, minus 0. 2 minus 0 is 2. And the units are meters. And the direction of the displacement vector is the x direction. Okay, and what is the total distance traveled? Okay, so now this is a little bit trickier because even though it started at 0 and it ended at 2, the object rate only went from 0 to 2 over the whole trip. It actually moved quite a bit, so we have to like see how much did it move. So first, it went from 0 to 3 meters here, and then it went from 3 meters to 10 meters. Okay, so we went 3 plus another 7 meters to 10, and then we went back to 2. So, oh my gosh, let's do it. The total distance traveled is 3 plus 7 plus, let's see, 10 minus 2 is 8. Okay, so yeah, if you want to check, right, it went, we can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in one direction, and then it came back 1, 2, 3, 4, 5, 6, 7, 8. So 10 plus 8 is the total distance that it traveled. So this is 10 plus 8 is 18 meters. Okay, let's try the next one. So you should try this one on your own. Pause the video now and try this one totally on your own, and then I'll show you the solution now in a second. Okay, let's get back to it. So hopefully you tried it on your own. Let's see. It says, what is the velocity between 2 seconds and 3 seconds? So between 2 seconds and 3 seconds. Okay, remember the velocity is the slope of the position time graph. So position time graph. Velocity is change in position over change in time. So this is like our rise over run. Let's see, so between 2 and 3 seconds is this part of the graph right here, right, which has a negative slope. Okay, so let's see what's this. We're going to go down 1, 2, 3, 4 meters and over 1 second. So we're going negative 4 meters is our rise, and our run is 1 second. So the velocity is going to be negative 4 meters per second. And since we're being asked about velocity, we have to give a direction. This is x position, so the direction is going to be in the x direction. So the object is moving in the negative x direction. Okay, that's good. It makes sense, right? We went in the negative x because the position was getting closer and closer to 0. We're moving like back towards our origin. Okay, what is the speed between 2 and 3 seconds? Okay, so notice, same time interval, right, between 2 and 3 seconds. So this is now the same part of the graph. The only difference here is they're asking us for speed instead of velocity. So we're going to have the same, remember that speed is the magnitude of the velocity, so it's going to be the same answer as what we had here for number 1, but now we can lose all of the information about the direction. So the speed is going to be 4 meters per second. Right, that's how fast the object is moving. We don't care about the direction anymore. We don't care that it was moving in the negative x direction. Okay, next, what is the total displacement? So total displacement, we want it over the entire time interval being shown in the graph. So 0 to 7 seconds. What is the total displacement? We are going from 5 back, from 5 back to 5. Okay, so total displacement. Let's write down the equation. Oh, I forgot to put my little arrows up here for the vectors. Okay, not a big deal. What is the total displacement? So delta x is the change in the position, final position minus initial position, and the final position is over here at 5 meters, minus the initial position is over here at the beginning, 5 meters. So 5 minus 5 is equal to 0. So the total displacement is 0 meters in the x direction. The direction is arbitrary here. What is the total distance traveled? Okay, so even though our displacement was 0, we did move over this time interval. We went from 5 to 1 and then back to 5. So that's 1, 2, 3, 4 units, or 4 meters one way, and then 1, 2, 3, 4 back. So the total distance traveled is 4 plus 4 is 8 meters. Okay, one more. Again, you try this on your own first. Pause the video now, and then I'll show you the solution. Okay, and we're back. So let's take a look at the solution. What is the displacement during the first 60 seconds? So between 0 and 60 seconds, displacement is the final position minus the initial position, which is going to be the final position at 60. Let's see, at 60, we're at 10 meters, minus the initial position. The initial position was at 0 meters. And so 10 minus 0 is 10 meters. Okay, and we're talking displacement here, which is a vector, so this would be 10 meters in the x direction. Okay, what is the velocity during the first 20 seconds? So velocity, remember, is the slope of the position time graph. So during the first 20 seconds is between 0 and 20 seconds. So we're like focusing just on this part of the graph. And we want to know the slope of this line segment. So let's see, it's going to be rise over run, right? So down 10 meters and over 20 seconds. Down 10 meters over 20 seconds. So the velocity is the slope, which is the change in the position over the change in the time. So we have to go negative 10 meters and over 20 seconds. So 10 divided by 20 is a half. Negative 1 over 2. And the units are going to be meters per second, and the direction is the x direction. So the velocity is 0.5 meters per second in the negative x direction. Okay, let's see, what is the velocity between 20 and 60 seconds? So this is the next one. Between 20 and 60 seconds is between here and here. So we're now going to find the slope of this line segment here. That's the velocity. So the slope of the position time graph gives us the velocity. Change in position over change in time. So let's take a look. What's the slope? It looks like we're going the rise over run, right? So up 5 over 10, up 5 over 10, up 5 over 10. So the displacement is 5 meters every 10 seconds. So now we've got 5 over 10 is the same thing as saying 1/2. And our units are meters per second, and the direction of the velocity vector is in the x direction. So it's in here, we've got a speed of 0.5 meters per second in the positive x direction. Makes sense. The object is moving in the positive direction, it's going this way. Okay, and then what is the velocity between 0 and 60 seconds? Okay, so now let's see. Between 0 and 60 seconds. There's no line here connecting these points. So really, this should say average velocity. Okay, but what is the average velocity over that time interval? Again, same business, change in position over change in time. The change in the position is x final minus x initial. The change in the time is t final minus t initial. So x final is 10 meters. X initial is 0 meters. The time final is 60 seconds. And the time initial is 0 seconds. So this is going to give us 10 divided by 60. And 10 divided by 60 is the same thing as 1 over 6. And our units are meters per second. Oh, I'm going off the page. Okay, 1 over 6 meters per second in the x direction, because this is a vector. Velocity is a vector. Okay, great job, everybody. Success.